So, folks, I'm going to be talking about why JavaScript should come with batteries today. And I was going to do a little bit of an introduction, but I guess I don't have to because these lovely folks already introduced me. But quickly again, I'm an engineer at the Deno company. I work on Deno Deploy and the Deno CLI in Fresh, and I do a bunch of web standards work at TC39, Whatwig, and W3C, things like Fetch and the Stream spec that you may be familiar with. And I'm a co-chair on WinterCG, which is a community group at the W3C that works on making JavaScript server-side runtimes more compatible with each other. So the premise of today's talk is going to be JavaScript is bare bones and this is bad. Or you may say JavaScript should come with batteries. And I'm going to talk to you a little bit about why I think this is the case and like what it really means for JavaScript to be bare bones and how we can / have fixed this. So skipped a slide here. So the first problem with JavaScript is that it has no extensive standard library or default tooling. When you start up a JavaScript project, you install Node, and that lets you run code, but that does not give you access to really anything much other than like file system and network I/O. If you want to have a linter or a formatter or a testing library or a type checker or like a type stripper because you don't want to wait for TSC because it's slow, or your benchmarking library or a documentation generator, or really any number of other things, you have to install a tool. You have to install the tool or you have to download some package to get the API or the tool that you need. And this is really unfortunate because first of all, there's a lot of different tools. You have to make choices all the time. And also it becomes really difficult for you to use these tools together. Like let's say I want to use eslint plus TypeScript. Just installing eslint and TypeScript, not enough. I need to go to a different website, figure out that I need to install the TypeScript eslint parser plugin and the TypeScript eslint plugin, add a bunch of configuration to my eslint RC file. Same for JSX, and like there you have to choose between which exact plugin I want. ESM pretty all right with eslint, but like if you want to use the most popular version of eslint, you can't use ESM for your config file, so you're falling back to CommonJS somewhere. If you want to use Jest in TypeScript, you have to do this whole dance again. So what I want to show you with this is like doing this dance once with one set of tools isn't enough. You have to do this like with every possible combination of like syntax, modification, or language and tool you want to use, and sometimes even between the tools themselves. So yeah, Jest in TypeScript doesn't work out of the box. You have to install something. And Jest with JSX doesn't work out of the box. You need to install something. And actually here, you don't even have to install a plugin for Jest, but you're installing a plugin for the transpiler that Jest uses. Not great. And then you want to use Jest in ESM, like you're just out of luck. There's an experimental option, but it like doesn't work with a bunch of different features of Jest. And like Jest for a lot of these things is not to blame. Like Node.js has been pretty slow in adopting some of the features that Jest needs to support ESM, but yeah, it's just not a good user experience. And once you've done all of this, you've installed a bunch of tools, you've set up a bunch of configuration and like a bunch of plugins to make these tools work together. Your Node modules folder looks like this. You have 200 megabytes, like, I don't know, 20 different packages installed. And like each of them you have to keep updated and they use up space on disk. And yeah, like they slow down your CI, not great. And then this doesn't even take into account that every one of these tools also has a config file that you need to configure. Like they usually don't come with out-of-the-box defaults. Like prettier is really an exception here. You have to set up, I don't know, an eslint RC file and like a package JSON file, and then you have to configure something for Next.js and a TS-config file. And then if you want to use ESBuild, you have a separate file for that. And Babel, you'll need a separate file if you want to use Jest. It really goes on and on and on. And this is really a tale of blood, sweat, and many, many wasted hours of trying to configure all of your tooling. And this is all before you've even written any code, right? Like you are just setting up your linters and your formatters and your testing framework here. You have not yet written any useful code. And this sucks. So how do we solve this? To answer this question, we can take a look at how other ecosystems solve this. So there's two ecosystems I want to focus on real quick here, which is Rust and Go, because those are both ecosystems that are about the same age as Node.js. So Go was released the same year as Node. Rust was released just a couple years later. So this is not like an age thing that Node is different. This is it's a matter of principle. And Rust and Go both have very good integrated tooling. for formatting, for linting, for testing, for benchmarking, for documentation generation. They have extensive standard libraries. They have really good API documentation. Something that, yeah, we're really lacking in JavaScript. And why is this great? Because it means you can get started on a project without spending any time on configuration. You don't have to have discussions with your team about using tool X versus tool Y versus tool Z, because everybody's familiar with the same tools and everybody likes the same tools, and there's no large amount of configuration to do, so there's not a lot of choices to make. And this also makes it really easy to switch between teams within companies or even between companies, because it means you don't have to switch out the tooling or the code you write or the linting that you're familiar with or the formatting that you're familiar with or the testing library that you like to use, because guess what? It's the same across all of them. They all use REST test or Go test or whatever, right? Everybody uses the same thing. This means you go to a different team, you just have to learn the new business logic, but you don't have to learn writing like a new dialect of the language. So let's do something about this. And who is a better person to do something about this than my boss, Ryan Dahl? He released Node.js in 2010. He really pioneered server-side asynchronous I/O in JavaScript. And then he got kind of bored of JavaScript for a bit and went to use Go for a couple of years and realized how nice things could be if everything is batteries included. And then back in 2018, he came back to JavaScript, reflected on what Node had turned into and the state of built-in tooling that it was at, and concluded that this was a problem worth revisiting. And also very actively realized that some of this was probably his own doing. So in May 2020, 10 years after the original release of Node, we released Deno to fix many of these problems that Node had. And that's what I want to talk to you about today. Deno is a next-generation JavaScript runtime that's incredibly simple to get started with, that's secure by default, that natively supports TypeScript and JavaScript, or in JSX out of the box, and JavaScript, obviously. Has built-in tooling for testing, linting, formatting, documentation generation, many other things. I can't list them all now. Builds on a lot of web standard APIs that make it really easy to onboard if you're coming from a browser, or make it really easy to switch between different runtimes because they're APIs that you're already familiar with. And since recently, it's actually completely backwards compatible with Node.js and NPM, and allows you to import packages directly from NPM and run them in Deno. And Deno is trusted by a lot of large companies, Slack, Netlify, Supabase. They all have large user-facing offerings built on top of Deno. Deno has, I think on a website, it says 250,000 monthly active users right now. So really quite a user base that is really happy with us. And at Deno, we really think about simplicity as like a whole system, right? Like simplicity in the whole system. We don't just want to focus on making it really simple to run code. We want to make it really simple to do your job as a developer, which means it's super easy to install Deno, first of all, right? There's a single command that you run. You can download Deno from your package managers, but really it's just a single binary. There's no OpenSSL dependencies. There's no DLL files that you need to install anything. It's just a single binary. And this makes it super easy to get started with Deno, which I'm going to demo to you right now. So I have a VS Code editor here that I have nothing open in. One of the things I quickly want to mention is that all of the code you'll be seeing me execute today, I will write live right now. I will not copy anything, which I think is important because I really want to show you that Deno does not rely on like hiding complexity away from you in a config file or in a pre-generated set of config files or in different tooling. Deno is just simple because we make a lot of choices for you and we give you a lot of tools out of the box. Yeah. Let me turn off Copilot because it'll be really annoying. Okay, so let me create a new file here. I'm going to create a TypeScript file, not a JavaScript file, because Deno can run TypeScript right out of the box. And I'll just log out a quick hello world. And then open this up and Deno run main.ts. And you can see, logging out hello world. Perfect. Let's just quickly prove that this is actually TypeScript and I'm not lying to you. So text string, I'm just going to refactor this a little bit to have a little function in between here that uses some type annotations so you can tell that I'm actually writing TypeScript. So type annotation right here. This isn't valid JavaScript, and it still runs. Okay, so Deno runs TypeScript out of the box. Where do we go from here? So JavaScript is kind of useless without I/O. So I want to demo a little bit about how Deno deals with I/O. Deno has a bunch of built-in APIs. Some of them are web APIs. We'll get to those in a second. And those are just available on the global, like fetch. But a lot of these are also APIs that are in this Deno namespace. And the Deno namespace is a space where we put all APIs that are non-standard, that are APIs that are specific to Deno, that are not they're necessarily portable across different runtimes. So for example, if you want to read something from disk, you do this with the deno.read text file function. One thing I can point out right here is you can see that Deno has built-in typings. You saw I didn't have to install any like types/Deno package or anything like that. Types just come out of the box with Deno. The only thing you have to do is install the Deno extension, and it'll pick up the types automatically. And the other thing you can see here is that this function returns a promise. So unlike a lot of built-in Node APIs, Deno is very modern and uses promises and async iterators for a lot of the async I/O. Which works really well with the new async await features in JavaScript. Well, actually, they're not that new, but they're pretty new if you're coming from some other tools. So I'm going to read a little file here. Let's read EDC password, assign this to a variable, and log it out. And let's run it. And you can see this doesn't work. And why does it not work? Because Deno is requesting access to EDC password. This is something that we call permissions. I mentioned earlier that Deno is secure by default, just like browsers, which means that Deno prevents dangerous I/O operations by default. Any I/O that you want to do in Deno, you have to explicitly opt in, which means that you can run pretty much untrusted code from the internet on your machine. And as long as you don't pass it overly broad permissions, it will be fine, right? Like your system will not be compromised. And you can like grant these permissions either by accepting the permission prompts, the interactive ones that you saw right here, or by passing some flags up front. So yeah, this tells you the API that the permissions requested by, the file that's being requested, and I can press Y here and press enter, and it grants the permission, and you can see my EDC password file. So that's great. That's some I/O. Let's talk a little bit about the web standard APIs that are built into Deno. So we really want to focus on making sure that we don't invent too many new APIs. Like obviously where we have to, because there's no browser equivalents, like for example, this read text file, we have to come up with new APIs. But in most cases, we try to really avoid this. So for example, Deno has no built-in way to do HTTP outbound requests that is not using fetch. So fetch is built into Deno, and this is the same way that you make HTTP requests in browsers. And this even goes slightly further because a lot of our built-in Deno APIs, like deno.open, return this FS file, which is a custom thing. But if I let me create one of these so you can see what it is. A lot of these have a browser web standard, like readable streams, for example. Like the stream primitive in Deno is the browser's stream primitive, which means that you just have knowledge transfer between the APIs that you're familiar with from the browser and server-side code that you're writing for Deno. So actually, let's do a quick demo of this. Streams are a good example. I'm going to have two files here, an input file and an output file. I'm going to create a file called copy in this directory here, and I'll just copy all the input to the output. So what I can do here is input.readable, which again is a readable stream from the browser, pipe to output.writable, which is a writable stream from the browser, and this returns a promise I have to await. And then I can Deno run this and grant it access. Oh, but I'm pressing the wrong button. And I should probably not misspell things. Let's try that again. And there we go. It's copied the file. Streaming copy, this is pretty easy. Let's do something slightly more complicated. So browsers also have a way for you to compress readable streams using something called compression stream, which is also directly built into Deno. I can just do pipe through new compression stream, gzip, and let's output this to a file called .gz. And if I run this again, Deno will now open the input, pipe the stream through this compression stream to gzip encoded, and output it to the output. So now we have a streaming gzip encoder in like 5 lines of code. This is all browser code. This is Deno specific, but like this is the same way you would compress things in the browser. And let me just prove to you that this is actually valid gzip compression. So if I decompress this, you can see my original EDC password file is back. Cool. So that's web standard APIs. Deno uses web standard APIs everywhere. This helps you to get started quickly. You learn once. You can use it both in the browser and on the server. And we really try to put a lot of effort into this. For example, we collaborate in a community group at the W3C called WinterCG, which tries to make using web standard APIs across different server-side runtimes really easy. And actually, WinterCG was founded by Deno and Cloudflare originally. So we have a vested interest in making web standard APIs work well. And we actually take this pretty far. For example, in the browser, you can import and run JavaScript from URLs, and the same you can do in Deno. And the reason this is safe in browsers is because by default, in browsers, sites that you go to can't maliciously attack your system in any way. And in Deno, it's the same. The permission system prevents you from doing bad things. So it's totally safe to run arbitrary URLs from the internet, which I will demonstrate right now. So we have a lot of built-in, like standard, we call this the standard library, the Deno standard library, hosted on our website, which is a bunch of TypeScript files or modules that come with a bunch of useful functionality. For example, this one is an example, but it's a script that allows you to pass in a file. Let me see whether it shows this anywhere. Oh yeah, it allows you to pass in a file and then it uploads it to GitHub Gist. And we can actually run this with just Deno run, https, denoland, std, /example/gist, and I'm going to be uploading my EDC password file. Again, permissions, so I'm going to grant it access to that because it needs a token to upload to the GitHub API. It wants to read my EDC password file. This makes sense. And obviously needs API access for GitHub. So I do that, and boom, I now have my EDC password file uploaded to GitHub. All from a little URL that I just invoked using my Deno CLI, and it didn't compromise my system in any way. And this obviously goes further than URLs, right? Like you don't have all of your packages that you may want as URLs. A lot of packages you want are NPM packages. So Deno can import and run NPM packages out of the box. And arguably, Deno is even better than Node at running and installing NPM packages because Deno doesn't require a package.json or Node modules folder. And this is because Deno is a runtime and a package manager in one. So it can do both the task of finding all of your packages to install, installing them, and then actually evaluating them at runtime, all in a single binary, which is really nice. So I'm going to give you a demo of that. The first demo I'm going to give you is like sort of like NPX, where you can pass NPM modules to Deno run, and then it will download them and execute them like NPX would. So Deno run npm:/cowsay. Cowsay is a package that you'll see in a second. Will print out a picture of a cow saying whatever you tell it to say. And one really fun thing about this is that with Deno, you'll see all of the random weird permissions that packages that really don't need them request. For example, npm:/cowsay requires access to your CWD. Don't ask me why. I don't know. It needs to access some package.json file and a default.cow file. I guess that's a template. And if I give it access to all of those, it prints out my cow. And I just want to show you real quick, if you trust a package, you can just pass a flag and then it will bypass all the permission prompts and you're fine. This is like the default mode in Node, right? Where you just disable all security. That's Cowsay. Let's do something more complicated where we're going to actually use a package at runtime. Express is a pretty popular HTTP server in Node. So why don't we write a little HTTP server in Deno using Express? So the first thing I'm going to do is import npm express. And even though Express is actually written in CommonJS, I can just import it as ESM in Deno. I can even import a specific version if I want to. And then I can just start using this. So const app equals express. And one thing you'll notice immediately is that there's no types. And this is because, actually, if I hover over here, you can see there's no types here. It just says code. This is because NPM doesn't ship with types by default. And as you may know, in Node, you have to sometimes install something from the @types module on NPM. And it's no different in Deno. So if you want to get types for Express, you have to do this @Deno types npm:@types/express. And this tells Deno you can fetch your types for Express from here. And then I can do app.get. So if I get the root, then I'm going to get a request and response, and I can do res.send hello world, and then app.listen, listen, and I have to pass a port to listen on, and I'll have it print out console log listening on HTTP localhost 8000. Okay. And let's run this. So Deno run main.ts. I trust Express. I'm just going to pass it permissions. You've seen the prompts enough. And it's now listening on localhost 8000. So if I open up a browser and go to localhost 8000, you can see it prints out hello world. Great. So I can run Express in Deno using npm packages. Nice. Let's head back to my slides. I want to show you some of the built-in tools that Deno has. So I told you earlier that Deno has a built-in linter. And actually, you've already seen this in use. Here, Deno lint is in my editor because I have the Deno extension installed. But actually, if I pull up my terminal here and run Deno lint, you can see it tells me that I have a problem here because I am using this request variable and it's not being used. And it says, if this is intentional, prefix it with underscore. So let me do that, and I can run Deno lint again. And now I don't have linter anymore. And all of this, no config file. I didn't have to install anything separately, just works out of the box. Another tool, Deno format, you've actually already also seen me use that. This is just also directly built into a VS Code extension. So if you do something weird like this or this, and you click on format, it formats it nicely. You can run Deno fmt, obviously, and that works too. And then if you want to run this in CI, you can run Deno fmt -- check, and it'll tell you if your formatting is wrong. All of this built in just comes right out of the box. One last little thing I want to show you, a built-in tool that we have in Deno is Deno KV. It's a key value database that's built right into Deno, ACID compliant. It's really built for serverless applications, has a built-in task queue, has support for key watching that's coming very soon. And the best part is no setup, no install, no import. You can just use it. It's just another JavaScript API that you call from your Deno runtime. So why don't we add a little counter to our first example here? I can open up a KV database by just running deno.openkv. And then I can start using this. So kv.atomic.sum. What this is this is creating or adding to a key. So I'm going to specify my key as counter, and I'm going to add 1 to it. So this, just increments the counter key by 1. Let me await that. And actually, this needs to be an async function. And then I can get the value that I just set here with kv get counter. And let me print this out like so. And now I can run this. So Deno run. I'm going to have to run with unstable because Deno KV is still an unstable API. I run this and I go back to my HTTP server. And if I now refresh, you can see it's counting. And actually, it started at 100 because I did this demo earlier already. But yeah, that works. And actually, one really cool thing I want to show you real quick is, so I turned off the server. Obviously, it doesn't work anymore now. But if I then turn on the server again and refresh, it keeps counting from where it last left off. Like this is a persistent database on disk. Yeah, let's head back to my slides. I only have a couple of minutes left, but I think there's enough to give you one more demo and give you one more explanation, which is everything you've seen so far is free, open source, MIT licensed, and you can download it for free from our GitHub repository and like build it yourself, hack, contribute to it, whatever you want. Which poses the question, like I said, I work at the Deno company. How do we actually make money? So Deno has a hosting product called Deno Deploy, which is a serverless JavaScript hosting platform that works great for Deno projects, but you can also run Node projects on there. And it supports NPM modules out of the box, has global edge distribution to reduce latency for your customers, has built-in persistence in the form of Deno KV. You can deploy directly from GitHub, and has an offering for enterprises like Netlify, for example, to offer integrations into your own product. And the reason I mentioned Netlify is because Netlify Edge Functions is actually built on top of Deno deploy. So let's do a quick demo of how to use deploy also. Before we do that, apparently I'm skipping ahead. One really cool reason why you want to use deploy is because like Deno, it uses all the same runtime and the same APIs as the Deno CLI, but they're backed by systems. They're really built to scale, which means that you can develop something locally with local APIs. And if they work on your machine, you can deploy to Deno deploy and be confident that it'll work when it's deployed and be backed by something that's really scalable. And an example of this is locally Deno KV is backed by SQLite, which is really robust database implementation. And when deployed, it's backed by FoundationDB, which is the same database that powers iCloud and is able to deliver extremely good scale for us. So back to my last demo here, I'm going to open dash.deno.com, which is the website where you administer your Deno projects on deploy. So I'm going to create a new project. I'll create a blank project. And the name of this project is Real Zebra 44. Let's remember that. And open back VS Code. So I'm not going to modify any of my code. This is exactly the code that I executed locally. I'm just going to run deploy-ctl, deploy -- project, Real Zebra 44, main.ts. So the project name and then the entry point, press enter and let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds. And we have a project deployed and running. Let me open this for you. We have a counter here, and actually you all can go to this website too. And if you go there, you'll see the counter increment, and you'll see other people's counters increment. This is a globally distributed counter now with just a single line of code here, or sorry, a single line of shell script. Okay, so that's the last of my demos, I think. Let me head back to my slides and finish up here. So in the quick recap, in a matter of 20 minutes, we started a new project from scratch with built-in formatting, linting a database, using NPM dependencies. We deployed it to the cloud. And all of this we did without any configuration, using no tooling other than the tooling that comes with Deno. Yeah, I think this is pretty great. And this is like, I've shown you 16% of the tools built into Deno today. This is a list of all of the subcommands we have. We used run, format, and lint and the LSP. Yeah, and there's a bunch more stuff. Like I didn't show you testing. Testing's great, or the type checker that's built in. Fantastic. Yeah, so that's what it feels like to build things with batteries included tools. I feel like all programming languages should work like this. Batteries included, first of all, significantly increases productivity, right? You don't have to deal with configuring your tools. Things just work. But more importantly, it makes it way more fun to actually program things. You don't have to deal with making jest work with ESM. No, it just works. You just write the code that you actually want to write and build really cool stuff. So yeah, that's my demo today. I think we're out of time. Maybe later I can give you another demo. But yeah, thanks for listening. Check out Deno and Deno deploy. And if you want to join our Discord, discord.gg/Deno.
Very cool. You know, the whole time I was watching your presentation, I was like thinking WebStorm and Deno have a lot in common, which is this idea of like batteries included, not having to like source all your dependencies and packages. So it's like that's kind of neat. So yeah. Paul, what are your thoughts before we jump into questions?
I love the build and deploy.
Mm-hmm.
Love the shout out for SQLite. Would have loved to have seen about testing.
You know, if you've given me another 10 minutes, I could have shown you testing.
I know. I was like, let's give you the rest of the afternoon. And I know we have a bunch of questions to go through from the audience. So instead, I'll ask my question, which is just so not fair.
Go ahead.
Edge as a special case. I believe your company feels strongly about this, that it's different than server side, it's different than browser side. Briefly, make the case for Edge.
Sure. Many services like e-commerce sites really work better if there's a lower latency between the server and the customer. And this is not just something I'm saying, but this has been proven, right? Amazon sells more things if they decrease their latency for their loading page. And Edge can help you do this. And Edge by itself is like, you can't just move your compute to the edge. This doesn't help. You need to move your data to the edge too. And you really need to have something that is set up to build Edge first. And that's something we're trying to build with Deno. And obviously, if you're building, like, I don't know, a site for some municipal government in Arkansas, then whatever. That doesn't need to be fast in Japan. But
yeah, those Arkansas people.
No, like, obviously it's great if it's hosted close to Arkansas, but like it doesn't have to be hosted close to Tokyo, you know?
Sure.
I wonder if there are any people from Arkansas in the chat.
Raise your hands if you're out.
Yeah, please let us know.
From Arkansas.
In fact, this will be a nice segue to the first audience question.
Yeah. What's the single biggest reason to use Deno? Because you get all the stuff that you get with Node, except you get a lot more stuff, and you don't have to think about it. It just comes out of the box. If you don't want to use it, you don't have to, but you have the option to use it. Yeah, that's
here's one that you should be able to give a quick answer on.
Well, I was going to say that person feels so incredulous in this. So when I read it, they can't believe what they're seeing. So.
Yes, Deno does support async await in the top level. I used it in the first two demos. You saw the await in my Deno.read text file demo. Yeah, we support top level await.
Excellent. This next one should be pretty easy.
Where can I host the Deno code? Only on Deno Deploy? No, Deno is totally open source, MIT licensed. We provide Docker images for you to deploy with, so you can host it anywhere. You can host Docker images. You can run on AWS Lambda, on Cloud Run, on Fly.io, on your own VPS, wherever you want. It's like any other server-side runtime. Run it wherever you want. Deno Deploy is really nice.
Thank you for preempting my question about is they got any pre-bundles for AWS or Google Cloud or anything like that. So cool.
Yeah.
Here we go.
Can you customize
not really able to show it, but maybe you could talk about it a little bit?
Yeah. So linting, we have a few customization options like prettier, like you can change the quotes that you want to use, but really try to keep it very minimal to make sure that you don't have to have a bunch of conversations with your team about like, do you want to use quotes or no quote, or like single quotes or double quotes? Because ultimately, who cares? You care? Okay, well.
No, I don't care. I'm glad you said that. For me, it's like, yeah, I don't care about this conversation.
Yeah, and then for the lint rules, we have a default preset, which has a bunch of recommended rules in it. But there's a website called lint.deno.com or .land, I forget. One should redirect to the other. Just try it out. And there you'll find actually the list of all of the rules. And if you really want to configure your linter, there is a config file that you can create. Well, you can create it in the Deno config file. There's a single config file for all of Deno, and there's some options to configure your rules in there if you really want to.
I've got a couple more to ask, but before, I know Colin had a couple of really good questions that I wanted to get in. Colin, what do you got?
Yeah. Let me see here. So I was kind of curious because the WebStorm team has to deal with this issue, which is like Deno has TypeScript support out of the box. How do you folks stay up to date with what's happening with TypeScript? Like, how do you stay lockstep with folks wanting to use some of the newer features?
Yeah. So actually, we ship the latest version of Deno ships a new minor monthly, and TypeScript ships slower than that. So we will have the new version of TypeScript in usually within about 1 or 2 weeks of TypeScript releasing it. And this is both for type checking, and actually most of the code that we execute with TypeScript, we don't have to do any type checking. So we have another internal parser that we use called SWC, which allows us to strip out types very efficiently. And we keep like 1 to 2 weeks lag usually.
Okay. So
that parser again?
Yeah. SWC. It's
okay. That's what I thought you said. Yeah.
So folks don't have to worry about like, oh no, I'm falling behind. Like you folks are on top of it. Another interesting thought I had while I was kind of watching your presentation, you talked about staying with like the web API as much as possible, but you also use that Deno type to kind of like have special methods. If an API gets created in the web API, what's the strategy? Do you deprecate the custom ones in favor of the web API ones?
Yeah, actually, we totally do. Let me think of an example of this right now. Yeah, so there's one that's was pretty early on. There's an API called navigator.hardware concurrency. It's kind of obscure, but it allows you to know how many threads your system has available if you want to do multi-threading, which is really nice. And originally, we didn't know about this API, so we had a Deno .cpus API or something that gave you the list of CPUs. And then before 1.0, we did deprecate that and switch to this navigator.hardware concurrency API. And the plan is if any new browser APIs come up, or other sort of standard APIs come up that we can replace Deno APIs with, we will. And obviously, we won't remove built-in Deno APIs because folks are using them today, right? We follow Semver, but yeah, we definitely adopt new stuff soon, quickly.
Okay, speed round of questions and then get you out of here. First one, can Deno, why don't I put this up? Here you go. Can Deno reset the counter using KV?
Yes, you can call kv.set and set it back to 0.
That makes sense. Okay, here you go. You had to know this one was coming.
Why Deno, but not fun.
Versus fun.
Look, I didn't see any seg faults during the entire demonstration, so. No, I'm just kidding. We had a bunch of seg faults too when we started. I'm happy to see other people doing things in the space. But yeah, Deno's pretty mature. We've been around for a long time.
Yeah.
So.
Okay, I'm going to ask you the question we've been asking everybody today because it's something we at WebStorm have been thinking a lot about. Junior developers, junior professionals becoming senior professionals over a career. What advice would you give to young folks who are just starting their career in programming?
It's a great question. I think, yeah, I would. The way that I really got like leveled up my programming is by starting to contribute to open source. Like there's a lot of people that, or a lot of open source projects that are looking for contributors. And I think it's a really good way to get other people to review your code, to point out issues that you have in your code, and to sort of see what other people are doing in a very collaborative environment. So yeah, if there's an open source project you're interested in, like contribute to it. Even if it's just something small, a documentation change, or maybe it's something really big, but yeah, contributing to open source, I think, is a really great way of like increasing like how good you are at writing and thinking through code.
That's such a good answer. I'm going to follow up to it. It isn't just about getting better technically. Getting involved in an open source project, you find a tribe, you find a group of people who value you, who find you valuable. It's really rewarding.
Yeah, totally. And like you learn a lot about responsibilities and like communicating with other people asynchronously. And that's something that's just super, super valuable nowadays, especially with a lot of remote work, right? You just want to be good at like asynchronously communicating, and open source is great for that.
Yeah. Kyle, you got any closeout for us?
No, I really enjoyed this talk. Like Luca said, I wish we had more time to give him to see more of the demos. But maybe we'll have him back and have like a specific webinar, right? So,
yeah, right.
Sounds good.
But yeah, on that note, thanks so much for your time. Thank you so much for the presentation. On that note, have a great day.
Thanks so much for having me. Bye, folks.